The Collatz conjecture, which is not proved, it's an open question in number theory. The Collatz conjecture says that if you start with any positive integer and then repeatedly apply this Collatz function, then eventually you get to the number 1. So before we made a list using nest while list to study this Collatz conjecture, and let me do that again, but let me do it in one step more sophistication. I'm actually going to make a function called Collatz list, which takes as input the starting value n, and as output returns the list that's made by the Collatz conjecture. So remember we did that with nest while list. And I keep applying the Collatz conjecture to whatever the starting value, so in this case the starting value is my input n. And I keep going as long as it's not equal to 1. So another way I could do it before I did pound not equal to 1 ampersand. Another way I could do it, since it's always going to be positive, is I can say as long as it's bigger than 1, keep repeating. Hey, that's going to give me the exact same value. So I'll do it this way just to see another way that works. So let's see what this Collatz list does for the input 7. Here's the output. Or what about for the input 25? Here's the output. Here's a question I have. For which input from 1000 to 2000 does the Collatz conjecture take the most steps to get to 1? So I think the Collatz conjecture, it's been tested numerically to be correct, probably for up to the tens of millions. So it's definitely going to work. We're definitely going to get to 1 for every input from 1000 to 2000. But which one takes the most steps before I get to 1? And you might think that the bigger the number, the more steps it takes, but that's definitely not true in general. For example, if I start with 2000, well, the very first step is to get down to 1000. So suddenly it has shrunk very much. So how can I study that question? How can I study the question of which input from 1000 to 2000 takes the most steps? Well, like seems to be the case lots of times, we're going to make a list of lists. So let me just call it new list. Hey, this isn't going to be a function, it's just going to be a list that I make. I'm going to make it using table. And I'm going to have each entry in this table be one of these Collatz lists. So it's going to be Collatz list of n, and I said I wanted it from 1000 to 2000. And I don't have to say the step size 1, that's implicit here. And I should put a semicolon after it so that it doesn't print this gigantic list of lists to the screen. Okay, it's done. I can tell it's done because this bracket on the right side isn't highlighted. So what's the length of new list going to be? Well, think about it. There's going to be one Collatz list for each input from 1000 to 2000. So total, it's going to be length 1001. There are 1001 numbers from 1000 to 2000. Okay, one way to think about that is there are 1000 numbers from 1 to 1000. There are 1001 numbers from 0 to 1000. So this is like that list, but adding 1000 to each of them. And now I want to ask, what's the longest of the inside lists? So maybe instead of new list, let me make a new one. Let me call it length list. This is going to be table. And how about length of x for every x in new list? So this is going to go through all 1001 Collatz lists inside of new list, and it's going to get the length of each of those. So maybe this one I will have it print to the screen. And then I want to know what is the biggest number that I see in this. So starting at 1000, it took length 112. So if I want to know what's the biggest, well, let me hide this by double-clicking. And now let me ask, what's the maximum of length list? Maximum is 182. What if I want to know how many lists from 1000, starting from 1000 to 2000, how many of them are length greater than 100? Okay, let's see how to do that. I'm going to do it using count and a pattern. I want to count this length list, and I want to count all x's such that x is bigger than 1,000. Oops, sorry, x is bigger than 100. So that tells me that for 313 starting values from 1,000 to 2,000, Collatz conjecture takes over 100 steps to finish. Okay, I could have done that using new list instead of length list. Let's see how we could have done that. Say I wanted to count in new list. So remember, this list, it has not just the lengths, but it has the whole Collatz lists. So I want to count all of these lists such that, but now I have to do length, such that the length of x is greater than 100. And because I did it correctly, I get the same answer. I get 313. And now let's see, what's the list that gives me 182? So I can get that using position. So what's the position in length list where I see the maximum, where I see 182? It's 162. And what is the list that gives that to me? So I can look at my new list, 162. So this is a length 182 list, and the starting value is 1161. So that's saying that for all the possible starting values from 1,000 to 2,000, the one that takes the most iterations to complete is the starting value 1161. Another way I could have gotten that, let me show it to you. Let me delete this. So let me name this position. Let me just call it M. And I could have gone to a function that we haven't talked about before called extract. I could have said extract from new list M. Okay, and that's exactly the list that we were just looking at. So M, it's kind of strange. It's actually itself a list of lists, because there's not just one curly brace, but this inside curly brace. And why does Mathematica like that format? It likes that format because it's what's set up to use this extract function.